Why does the sky look so different in different seasons? That's what we're going to talk about today. Hi, this is Jill from the Northwoods talking about nature right outside our front door. Well, I think the first question we have to answer is why is the sky even blue at all? And the idea is that you got the sun, right? And the sun has all sorts of gases and particles, and it has all or many of the various colors in it as it's beaming light towards our Earth. But then the sun's light interacts with the gases in our atmosphere. And so this is kind of how it looks, is that sunlight itself actually looks whitish because it's made up of most of the visible spectrum in it. But when the sunlight hits the Earth's atmosphere, it collides with molecules, including nitrogen and oxygen, which makes up a lot of our atmosphere. And these molecules are much smaller than the wavelengths of visible light. So they're very small, right? So you sort of think of it as like little tiny fuzz. What is a fuzz? But anyway, they're very tiny particles in there, and they scatter the blue and violet light much more efficiently than they scatter the reds and the oranges. So the reds and the oranges sort of get lost. So why is the sky blue? Because the blue gets less scattered than the reds. Does that make sense? And so our eyes are also more sensitive to blue light than violet light. Some violet is in the ultraviolet range. You ever seen like black light at like some weird rave parties? You've probably seen that. And a lot of the violet light, that's purplish, gets absorbed by the upper atmosphere. So to us, the sky mostly appears blue because everything else mostly just gets taken out. So you kind of think about that. You know, when you see sunsets or sunrises, the sun has to travel through a thicker part of the atmosphere, and then most of the blue light gets scattered out, and then we start seeing the reds and the oranges sort of on that horizon. And on cloudy or hazy days, the larger particles of air scatter all the wavelengths, and everything just kind of looks like white and gray. You know, other planets are going to have different things. Mars looks pink because of the dust composition. Titan's, which is Saturn's moon, looks orange because it has a thick smog to it. So that's kind of how it figures out. This was kind of discovered back in the 1870s by a guy named Lord Rayleigh, I think is how you would say his name. They called it Raleigh's scattering. But that is essentially why the sky looks blue. And if you ever talk to pilots, they'll talk, or been in a plane yourself, that you'll see the atmosphere as that deep cobalt blue, since the higher atmospheres has less air to scatter it, so the blue's even deeper, and then it fades towards more black as you get higher up. But what we're going to talk about is seasons and how that affects why the sky looks so blue differently in seasons. So you might have actually stood on your porch in October, had some pumpkin spice coffee in your hand and say, why does the sky look so deep blue? Why is the air so crisp? It's been so washed out, all the time. And now it's just so brilliant. We always kind of notice that brilliant. I notice it in September. I start seeing that really brilliant blue sky. And so the sky sort of changes characteristics over seasons. Its color, its clarity, the way the clouds kind of move and interfere or interact with the colors. And at night, it's even a whole new cast of how the stars sort of take up what they look like too. So when you think about the autumn sky, because we're in autumn right now, it gets that deep blue. The fall skies are sort of famous, sharp, vivid October days when you can just sort of see for miles as if, suddenly everything got more clear. It's a beautiful bit of physics, I guess, involved in that, is that cold air can't hold as much moisture as warm air. So the autumn air naturally is drier. That's why your skins are all like, I have to put lotion on now. It has fewer water droplets. So there's less haze, and those blue wavelengths of sun are more pure. And it gives us a more saturated blue that we're used to looking at. during this particular period of time. You'll notice a little bit about that, like right now, because it's getting chillery, more chilly outside. It takes less to make it rain. That how much moisture comes into the atmosphere. We're not going to talk about it today, but there's a thing called dew point. And basically, as the air warms up, it can hold more water. And when it releases water, it's a higher threshold. But this time of year, the threshold is less, but the air is also much more dry. Like I said, our skin is drying up. We're using more lotion. So when you have those air being so dry, you start to see that happen. When water gets in the atmosphere, like I mentioned before, you start getting water vapor, the blue fades a little bit and the sky gets a little bit more white. That has to do with how just how the light is absorbed in that. Artists notice this for a really long time, and artist textbooks. They called this the Hudson River School of Painters. Thomas Cole, Frederick Church painted these landscapes with various cobalt skies, but they knew that the October light, revealed much more, had much more of an edge. And that way it also provided a better backdrop for our beautiful fall leaves. And so I think that's why it feels the way it does. Now we think about winter, right? When we have winter skies, there's even less moisture in the air. How much moisture it takes to snow is much less than what it takes to rain. So everything looks very sharp. And if you look at the night skies, they twinkle in a very specific way in wintertime that they don't in summertime. But that's because we are seeing them much more clearly. We are able then, so if we do astronomy in wintertime, we will see everything look much more defined. The cold air is denser, like I said, usually cleaner too. So you'll notice a lot of air quality problems goes away in wintertime. Dust settles out, the humidity drops, and it almost becomes this perfect window. That's why some of the best astronomy observations that happen on Earth happen in wintertime because of that. Or you may even notice that when we put telescopes up, we tend to put them up in high atmosphere, less things to interfere with the telescope, and in colder areas. So also mountains just tend to be colder. Now we're getting to the place where we're actually just putting them in orbit, where it's very cold, no moisture, and we get a crystal clear picture of it. But wintertime, on Earth, we get to see stars. It also means, too, that if we get auroras, like aurora borealis, the northern lights, the sun has a flare, you may see it. There was a really good one that happened in May, but in warmer period, again, more moisture levels, and so it's just not going to be as crisp and clear as when you have an aurora or northern lights happen in wintertime. So many times we could get auroras happening in warmer seasons. We just can't see it very well. And so a lot of places won't even give you an alert because it's probably not worth going out and looking at. It's too faded. But wintertime, fall time, you get out there, you go to the cornfield, and you see the beautiful auroras because the sky's going to be crisp and you're going to get a vivid picture. So that's kind of why we sort of see it differently. I came up from the North Woods, which means I grew up at the very tippy top of the United States. And because it is so cold up there, so crisp up there, we had northern lights all the time and they were beautiful. We could see the stars just shine when we were up there. And we didn't have pollution. I go to Chicago and there was a great telescope there, but it often had a lot of pollution. And so you had to go there on days where it wasn't hazy and it wasn't polluted. So you kind of take that out. When my brother and I went to Iceland, crisp, cool. We were 30 miles from the Arctic Circle. Beautiful. So that's why you kind of see. So those cold darknesses, that's why the stars are so bright. You kind of think about candles and lanterns and all sorts of lights being a part of winter celebrations. because they look so beautiful at that time of year. So if you step out on a January and look up at Orion's belt, or you look at Sirius the dog star, and you see the constellations just glisten at that particular time. Astronomers would call this the winter hexagon, where there's a giant pattern of stars that surround Orion, and it marks the cold season across the northern hemisphere. So even though our ancient ancestors maybe didn't have telescope, they were able to see those lights better in the wintertime. So that's why it works that way. In spring then, suddenly it's spring, the sky sort of loosens its grip on that deep cobalt color. The crystal clearness of winter starts to fade, and we get kind of more of a silvery, shifting blue. The spring air is restless. It's starting to warm up. Cold fronts are meeting clouds, and that humidity is creating turbulence in our atmosphere. And that's why sunsets in spring are so spectacular. Those layers of scattered light really give you deep colored streaks of violet, pink, gold. That's where you get those big colors. Emily Dickinson wrote about a certain slant of light, and she was describing that pale, angled spring sun that makes everything just look so beautiful. But spring skies aren't exactly clear. The stars are not sparkling like they were. The auroras aren't coming through, like I said, as they used to. But the moon's a little softer. The sunsets are more beautiful. And so it has a beauty that's different as the whole world is kind of coming back around us, coming back to life. And then comes summertime, the heat and the haze. So you think about midsummer, hazy. Maybe the skies are more white and gray, that you're not seeing as much blue. The warm air holds more water vapor. The water vapor scatters the light. And instead of those short blue wavelengths that dominate right now, getting through to us, looks more milky, looks a little bit more silvery. And so that natural haze, too, you get more pollen, more dust. There's, of course, wildfire smoke, which we had a big time with this year with smoke coming down from Canada. Even something that's called ozone, which is, we won't get into right now, you get kind of a blur in July. The horizon loses its definition. The sun sort of burns through kind of a more glowy veil. And even our perception changes. The heat causes the light to shimmer a little bit. You get waves of rising hot air. You can see that, right? My friend was talking, we were bird watching in July this year, and I have a blue car. And she said, "Your car is so hot right now, I can't see this bird because all I see are these shimmering waves of warm air." And it's like screwing up her binoculars, which I thought was kind of interesting. But even in this time, the bees buzzing in the clouds, it has its own kind of beauty with the thick atmosphere already there. Ancient cultures used to see the summer skies as a protective blanket, that we're being shielded from this celestial fire during its hottest period. Norse stories even went on to make it sound like the sky was made of a skull of a giant, which is kind of wild. But that's the idea, is that explaining why you sort of have this white hazy piece. And, like I said, as we rotate around the sun, the sky shifts around, and each night is a little bit different. I think it's one of those things that we may see fewer stars in the night sky in summertime, but we will still see the bright ones, the ones that are in Orion, the Sirius dog star. And in summer, our planet has swung around to the opposite side of the sun, so we're sort of viewing the more crowded center of our Milky Way. So it may be not as sharp, but we have this soft river of starlight visible on those dark nights. And, that's why if you sort of think about it, Orion disappears in June. You might see Sagittarius rise a little bit differently. And that's how these calendars got built, were our ancestors observing the nature around us. The Egyptians used to watch the dog star Sirius rise right before dawn, and that would announce to them the Nile is about to flood, and it's gonna be a start of a new year. The Greeks would watch the Pleiades cluster so they knew when to plant, and the, North Americans, natives here, would watch the Great Bear, which is the Big Dipper, slowly march across the sky and, give the idea of what time of year it is. So, while you're looking at each of the night skies, it's great to notice just the differences. Maybe you could start a sky journal. Maybe you could start watercolor painting. My friend she just started watercolor painting, and wouldn't it be fun if she painted every night sky? But maybe write it down. Write down the colors, the temperature, the clarity, what stars do you see? And kind of give that idea that each season has its own beauty. And start checking out those patterns. Look for the true cobalt days of fall, the first brilliant nights of winter, and the first faint Milky Way of summer. And you'll start to realize that our sky is not static. It is a beauty. Every single night is a beauty, I think. And that's where you can start picking up apps like I said, I do Stellarium. There's a few other really great apps out there that will make you help you enjoy this time that we have on this earth much more. Thanks so much. Have a great day. If you have any comments, if you have a favorite season, put it in the comments right here. Let me know what your favorite season is. What is your favorite sky? Do you love the hazy summer or the October blue or the crystal clear of winter or the brilliant sunsets of spring? Let me know. I'd love to hear from you. Thanks so much and have a wonderful day.